So quiz number 5, let's start here. It says, for each question, prove each identity. Show all steps. Basically, when you're trying to do a proof, the rule is, if you think it, write that down so the marker knows that you've done that step. You see, you could technically say, because I'm not going to give you a false proof, you could technically, Spencer, just go like this. Oh, sine theta equals sine theta. I did it all in my head, which I'm sorry is not acceptable. So I think the right-hand side I would definitely write as sine theta. Left-hand side, any suggestions here? Gotta try something. That's usually one of my first strategies. Cosecant is 1 over sine theta minus cotangent is cos theta over sine theta, all divided by secant is 1 over cos theta. Hey, I have a 4-level fraction. It's 1 fraction, Trevor, over 1 fraction, so I can say, how do I divide by 1 fraction, flip it and multiply? I don't need to use that complex fraction trick. So I did that. Well, I got 2 fractions being multiplied. Multiplying fractions, that's the easiest operation. Lattice top times top, bottom times. So my next line is going to look like this. I'll still have that 1 over sine theta dropping down. Minus, and I'll have a cos squared theta over sine theta. I said, well, this is very convenient. I have a common denominator. Here I have 1 single term. Here I have 2 separate fractions. I might want to write them as a single fraction. Why, I think I would. And when I do that, I get 1 minus cos squared theta all over sine theta. And it was right about here that I got my nerdy adrenaline rush where I went, aha, I see it. What do I see? Ah, 1 minus cos squared theta. You know what? I should have changed colors, Mr. Dueck, because you're doing a different color for each step. So 1 minus cos squared theta all over sine theta. Then I went to black. Sine squared theta over sine theta. And then I can say, Spencer, how many sines on top? How many on the bottom? How many left and where? And I am, lo and behold, now these are very tough for me to tell you how to mark yours. If you did that, which is probably the most common solution, you would get 4 out of 4. If you did something different, leave it blank, and at the end of this, bring it up and show me, and I can glance at it and tell you what I would give you. It's really tough to explain how I mark these. But it's basically a half mark or 1 mark for each logical step, and I know what to go looking for. And I know there's 2 or 3 other ways to get here as well. Number 2, or B. Well, I'll do this. Suggestions? Yeah, I'll try rewriting everything in terms of sine and cos. Secant, that's 1 over cos. All over cotangent, that's cos over sine, plus tangent is sine over cos. Alex, is this a complex fraction? It is. And it's not 1 fraction over 1 fraction. How do I divide by a fraction? Flip it and multiply. This is like more than 1 fraction over more than 1 fraction. Well, 1 fraction over more than 1 fraction, but multiple fractions somewhere. Yeah. No, actually, Mr. Dueck has showed you a wonderful, I'll call it a trick. It's to say, look, you got a cos, you got a sine, you got a cos. Your common denominator is cos theta, sine theta, or you could have written sine theta, cos theta, over 1, over cos theta, sine theta, or you could have written sine theta, cos theta, over 1. I'm going to multiply by a 1, because that is a 1. Funny looking one, but it's a 1. But it's a carefully chosen 1. It's actually saying, hey, how about common denominator? Why? Because Vlad, when I do this, in this first term, the cos will cancel, and I'll be left with a sine theta on the top. That's nice. On the bottom, in the first term, the sine will cancel, and I will be left with a cos squared. And in the second term, the coses will cancel, and I'll be left with a sine squared. And I said to you, Asar, always go from the top to the, always look from side to side, from side to side. What's on the top over here? What's on the top over here? Here's a hint. What's on the bottom over here? It's invisible. What do you, oh! What is cos squared plus sine squared? Thank you. You having a little hoarse voice this morning? Okay, don't worry about it. If you just wrote sine theta, if you didn't write the over 1, I'm totally good with that. But then I would do my traditional nerdy sign off. Q, E, D. There are other ways to do this. You could have written this as 1 fraction by finding a common denominator, and then you would have had 1 fraction over 1 fraction. How do I divide by fraction? Flip it and multiply. You can get there totally via that. It's about, I think, 3 more lines, and if you show it to me, you're good. If you didn't get this, show it to me, and I'll tell you what I would give you. For those of you that are skipping out today, I rebuke all of you that are skipping out. I should give a 0 out today. We'll see. Turn the page. This question here is probably going to involve the most work. It says they want cosine of theta minus beta. You know what? I know that that's cos plus sine. And that's on your formula sheet. I actually have, because I just taught this again, I've happened to memorize them, but I'll forget these again in a few months because they all look alike to me. And then some of these I can plug in. For example, cos beta, okay, that's a -3/7. Do I know cos theta? Not yet. Oh, but I know sine theta. That's a -9/13. That's good. Do I know sine beta? Not yet. Okay. Now, I'm going to look at theta, which they said is in quadrant 1, 2, 3. When they told me sine, what they really said was that y equals -9 and r equals 13. What does x equal? Well, it's going to be the square root of 13 squared minus -9 squared. Except, wait a minute, in this quadrant to the left of the y-axis, I actually think x is going to be negative. 13 squared is 169. 9 squared is 81. 169 minus 81 equals root 88. Oh. If possible, use exact numbers. Eric, they don't want a decimal. Now, if you left it as root 88, I'm okay with that, but technically, this is actually -2 root 22, because 88 is 4 times 22, so the square root of 88 is the square root of 4 times the square root of 22, and the square root of 4, I can do. What that means is the cosine of theta is -2 root 22, or root 88, all over 13. We'll tackle that a bit later. While we're at it, let's look at beta, which is in quadrant 2, which means my y's are going to be positive, but my x's are going to be negative. They told me that x is -3 r is 7. Y is going to be the square root of 7 squared minus negative 3 squared. I think y ends up being root 40, which is 2 root 10. Is it root 40? Yes? Keep nodding. So sine is going to end up being 2 root 10 over 7. I'm going to get 13 times 7. 13 times 7 is going to be 70 and 21. 91? Isabel, what's a negative times a negative? Okay, I know that. How do I multiply 2 root 22 times 3? It's very simple. Numbers times numbers, roots times roots. It's 2 times 3, which is what? Root 22 times no other root is just going to be root 22. Plus 13 times 7, 91. Negative times positive, negative. 18 root 10. Final answer, because I have a lovely common denominator, is going to be this, all over 91. 6 root 22 minus 18 root 10. Now, before you start yapping at me, how did I give out part marks? Am I right? Is that what the answer is, or did I make a mistake? It didn't sound familiar to me, but maybe I used a different version of the quiz this year. Which version did I give out this year? Quiz version number 1? Trig quiz 5, version 1 answers. How did I give out part marks? Let's find out. Come on, computer. Slowly load. So, I should have made this question worth more. I think I gave a half mark if you found X successfully, a half mark if you found Y successfully in the other one. I gave you a half mark for that and a half mark for that. If you didn't write it as a common denominator, as one single fraction, I won't freak out. Any other questions about this one? Okay. Number 3 says find an exact expression for sine of 105 using the sum and difference identities. I said, okay, that's the sine of 60 plus 45. That's the 1, 2, root 3 triangle where that angle up there is 60 degrees because that angle down there is 30. And 45 is the 1, 1, root 2 triangle. I said sine of alpha plus beta is sine cos plus cosine. And I ended up with root 3 plus 1 all over 2 root 2. And there's how I gave out the part marks in case you're interested. Did anybody rationalize the denominator? Smart aleck. Root 6 plus root 2 all over 4. Man. You should be at least a little impressed that I did that all in my head. Anyone else? The last identity. Double angles is... Okay. Link, there's my T-table. Brianna, suggestions. What'd you try first here? Yeah, I caught you talking to Eric. You can do better, trust me. Sorry, what? So you said cotangent is what then? Thank you. What'd you do on the left-hand side? Oh, you know what? I would have written a fraction bar first. I always teach kids, do some of the obvious writing first, because that way it's no longer blank. It looks less intimidating. It always drives me crazy when I see kids leave a written question completely blank, because often I'm like, hey, even writing the fraction bar would have relaxed you, because you would have gone, oh, I guess there's something on the top and something on the bottom. Like, there's good thinking there. Keep going, kiddo. Change what? Top or bottom? What are we looking at? Top? Yep. Yeah, I would have picked, because cos 2x, there's 3 possibilities, but since I have a positive one, let's pick the one with a -1 built in so that those cancel, which is 2 cos squared minus 1. By the way, technically, I should put it in brackets just to be safe. In this case, the brackets don't make a difference, but had that been a minus sign right there, I would have had a minus minus. This would have become a what? See that? I didn't even put it online. Hey, what'd you do for the bottom? Yeah, this one's a little more stuck with it. How's that help? Well, on the top, I get 1 take away 1. Yay! And I end up with 2 cos squared x all over 2 sine x cos x. Can I cancel? Is it factored? It is, because there's no plus signs or anything in there. That means it's all timesing, so it is factored. So are you saying, if I hear you correctly, that I can cancel out a 2? Why, yes. Oh, and how many coses on top? 2. How many on the bottom? Oh, you're saying I can cancel out one of those, and lo and behold, I'm left with that. Woohoo! Give yourself a score there out of 4. Now, this quiz is out of a total of 16. You can give yourself a score out of 16. Also, if any of you need to come lawyer with me because you did your identities differently or you didn't get to the same area, now is the time. By the way, for what it's worth on that quiz, Brianna, did I use a calculator at all? Once to do a squared. If the numbers were smaller, all of those are fair game on your final exam on the non-calc section, which would mean there's no way I'd be asking you to find the square root of 88 and writing down that it's 9 point something, something, something. These are all non-calc questions, okay? Hey, we looked at applications of trig functions. We said you need your graphing calculator, and again today you're going to need a graphing calculator. And again today, if you have one, you're going to sheepishly come up here and bring me some collateral, and I'm going to get thoughts about you. So the homework I gave you was page 367, 366. And I'm willing to bet there were probably questions about some of the homework. I'm hopeful number 1 went okay. I suspect perhaps number 2 might have been some trouble. And I can't remember, did I hit record? I did. Questions from the homework. And take it away, Mr. Wilson. I can't give you a rule here. Okay. First, here's what I would do. First of all, what's t being measured in? Seconds. What's the period of this graph? I might try from 0 to 30 seconds, or I might go from 0 to 60 seconds. Why from 0 to 60 seconds? Because in our society, that's exactly 1 what? Minute. So I might either of those would be right. There's no right answer. A wrong answer would be, oh, I'm going to go from 0 to 15 or 0 to 70. Get one whole graph in. Okay. So I would probably, if they wanted me to write a suitable window, my x's going from 0, I'd probably go 60 and go with the whole minute. That would give me 2 full waves. And as a scale, 60 hash marks in that small screen would be terrible. I'd go up by 5s or 10s. You know what? Probably by 10s. Okay. That's how I would figure out the x's. I look at what the x is. If it had been days and they were talking about years, I'd go 0 to 365. There's no right answer, though. If you went for 2 years, that would be fine. If you went for half a year, I'd glare at you. But if you're able to get all of your data to answer the whole question in that window, then I'd say, fine. But I just think it looks yucky. Vertically, almost always I'm going to start at 0 unless it goes negative for some reason. I like to see the ground or the beginning or the, I guess 0 in this case would be silence. What's the vertical displacement? What's the amplitude? I go 60 and 20. I'd probably go to 80. Going to 100 would also be accepted. Going to 75, then I would say, hey, you're chopping off your graph. And you'll be able to tell, because when you graph it, you'll see parts going off the screen. That's when you pick the lousy window. That's the only quote-unquote wrong answer. Probably go up by tens as well. There, I'd probably do that. Okay. What did they say in the back? Did they actually pick one? Or did they do the answers may vary? Yeah. Okay, so they went from 0 to 40. They did 40 seconds. I think that's a stupid window. I would do 30 seconds or 60 seconds. Do one whole graph or two whole graphs. They didn't go to the ground. They said, what's the lowest this graph gets? You said the amplitude, the vertical displacement, Alex, was 60, and the amplitude is 18, 20. They went 60, take away 20, 40, 30. I like to see the ground. It's just me. Is that all right? Yeah? Any others? One E. Okay, so now I got to type all this in. First thing, I got to make sure I'm in radians, because I bet you I'm in degrees, because every time I boot this thing up. Clear. And I'm going to go 18 sine pi times x divided by 15, because I got to use an x instead of a t, Caitlin. Close the bracket off, plus 60. Window, I'm going to go from 0, I'm going to go 1 period. So 0 to 30, in which case I think, Alex, I'll go up by 5s. 0 to 80, up by 10s, graph. Siren gets louder, siren gets quieter, siren gets louder. Is that okay so far, Caitlin? Now let's answer your question. It says, the background noise level is 45 decibels. 45 is a number, so I'm looking at decibels. Is that an X value or a Y value? So you notice I'm just looking at the units. I have no idea how sound works, but I can look at their equation and figure out whether V is measured in decibels or whether T is measured in decibels, because they'll always tell me in the question somewhere. It's V, which is sitting where the Y is. Oh, so you know what? If it's a Y value, what they want me to do is they want me to go like that. And graph. And then they're asking between which two times in the first cycle of the siren alarm, here is the first cycle, which two times won't you be able to hear the alarm between those two times? Can you find those two times? Yeah, second function, calculate intersection, first group, second guess. Do I need to go further, or is that okay? Yeah, there you go. I guess you wouldn't hear the alarm for a split second. It would fade out. Well, the background noise would cover it up, which makes it kind of a stupid alarm. But, oh well. You'd clearly hear it here. Any others? Okay, today we're going to go one step further. Today we're going to say, what if they don't give me the equation? What if it's purely in a word problem? What if it's purely given to me as a description? Lesson 10, page something or other. Page 369. There's going to be two of these on your test. One is a great big written question, and then one is a multiple choice question. In the multiple choice question, I'll give you the equation and ask you to do something with it. In the written question, I won't give you the equation. I'll actually give you a description. You have to find the equation. And my approach for all of these, Tyler, is if they give me a trig word problem, I do a sketch. And in particular, I'm interested in three key ideas: the highest point, the lowest point. Oh, and if I know the highest and the lowest, I can find the middle. And then one more point anywhere on the graph. If I can get that, Asar, I can get the equation. Show you what I mean. It says, in the previous lesson, we were asked to solve problems where we were given the equation. Today, we're going to find the equation. Here's an example. A sinusoidal wave shown, this one here, has a maximum value of 50 and a minimum value of 10. And I told you I'm always interested in finding the highest and the lowest. So I'm going to put a little hash mark right here, and I'm going to write a 50 so it stands out. I'm going to put a hash mark right there. I'm going to write a 10. How high does this graph go, Asar? How low does this graph go, Isabel? Where's the middle? What's halfway between those two? Now you can see it on this graph, but if you didn't have it on graph paper, could you figure out what halfway between 10 and 50 is? Yeah, add them up and divide by 2. It's 30. This is really a point I'm interested in as well. You know why? Because in my equation, that's my vertical displacement. This graph used to start at 0 high in the middle. Now the middle is 30 high. You okay with that? You got to memorize how, where all these parts go again. We did some graph by hand last test. Remember that, Dominique? Yeah? Okay. Oh, and what letter do they want me to use instead of Y? I'll be consistent. What does the letter A stand for? Amplitude. Okay. Do you see why I always want highest, lowest, and middle? Because can you figure out the amplitude pretty easily now? Starting in the middle, how far up and how far down does this graph go, Vlad? 20. Okay. Oh, they want me to graph it as a sine function. Usually I'll let you pick whichever is more convenient, and usually it'll be cosine, to be honest. But they want me to graph it as a sine. Period. Now, I got to be careful. What appears here is not the period. What appears here, don't write this down, don't write this down. We symbolized with B. Don't write that down. Because what is B? I had you memorize something. I said B was equal to something, something over the something. Caitlin, you know what? Why don't you all just write down 2 pi over, but don't put the period there yet. Let's just stick that whole expression in. Here's one top, here's another top. How long is the period of this graph? Let's see. Looks like we're going up by 4s. So right here is 24. Right here is 56. How long is one wave? Sorry? 32? I'm just going to write 2 pi over 32. Now I know that's pi over 16, and if it was multiple choice, I would then reduce to go find that answer. But if it's written, I don't care if my fraction's not reduced. I'll just live with it. And we had the phase shift. Now, this is where we needed to distinguish, Eric, whether we were doing a positive sine, a positive cos, a negative sine, or a negative cos. If I was doing a positive cosine, Eric, I would start right here, because positive cosine starts up high. If I was doing a negative cosine, Dominique, I would start down there. I would phase shift 8 to the right, because negative cos starts down low. If I was doing negative sine, I would start with a phase shift of 0, because negative sine starts in the middle, which in this case is at 30, and goes downwards. They said they want A to be positive. The first place I'm in the middle and going up is right there. I want a phase shift T minus 60, 16 to the right. So what's our strategy going to be? To do a sketch? Sometimes they'll provide one, usually they won't. Vlad, I want to find the highest and the lowest, which is usually easy to figure out from the question. And if I know the highest and the lowest, don't I know the middle? Which is what? The vertical displacement. Hey, I filled in one thing. Oh, and then I can get the amplitude. Hey, I filled in 2 things. Usually the period will be pretty obvious, because it'll say goes around every 30 seconds. I think that's the period. Or goes around every 42 seconds. I think that's the period. Or the tide changes every 3 hours. I think that's the period. So B will be 2 pi over whatever that is. The trickiest part is the phase shift. We'll almost always try and pick the easiest phase shift. If we can do a phase shift of 0, that's usually the easiest. Example 1. A nail is caught in the tread of a rotating tire at point N in the following sketch. Can you see as the tire rotates, nail goes up, nail goes down, nail goes... Hey, that's a trig function. And I think I said to you last day that anything that moves in a circle can be written as a trig function. The tire has a diameter of 50, rotates at 10 revolutions per minute. After 4.5 seconds, the nail touches the ground. Okay. What's the lowest point here? Because I said I'm interested in highest, lowest, and middle. What's the lowest point on this graph? This one's pretty easy. 0. What's the highest point? Can you figure it out? They told you something about the tire. Alex, what? 50 because the diameter. If the diameter is 50, 50. Now those numbers are not going to appear in my equation, but I need those numbers so that I can conveniently find the middle. Dominique, how high is the middle? 25, which tells me that as an equation, it's going to be a plus 25. By the way, A says use the information to write a scale for each axis. I'm actually just going to write a couple of points. Well, I guess there's a scale. Going up by 25. Okay. Oh, and let's write the height as a function of time. Oh, I can also do the amplitude, which is what? Here's the middle. How high, how low, how high. Also happens to be 25. In this case, our vertical displacement and our amplitude are the same. Now, I notice we start in the middle. Which trig function starts in the middle? So if I had my choice, I would pick sine. Thankfully, they actually told me to do sine, but you know what? I would have picked it if I could have. Are we starting in the middle and going up? Or are we starting in the middle and going down? Oh, positive sign. Which means, what's my phase shift if I'm starting right on the y-axis? 0, which is why they didn't bother putting any t minus or t plus something. I can just go t. The last thing I need to figure out is b, which is 2 pi over the period. Let's see. There's 2 ways I can figure this out. The first way is to say it rotates 10 times in 60 seconds. By the way, I replaced it in seconds because I noticed up here it said time in seconds, yes? If it takes 60 seconds to go around 10 times, how long to go around once? Think about it. 6 seconds. The period is 6. Oh, and by the way, that's 4.5 right there, because it says after 4.5 seconds the nail touches the ground. I think I could have figured it out from that as well if I was really clever, because I could have said, hey, that's 3/4 of the period. I think 1/4 of the period is 1.5. It's 1.5, 3, 4.5, 6. There's my 4 points of my graph. On your test, I'll give you some kind of a word problem, find the equation, and then almost always part B and part C will be asking you to do something. And Caitlin, you know what I'll ask you to do? I'll either give you a y value and say find the x value, send the y value shooting across, intersection, or I'll give you the x value and say find the y value, trace. Regardless, let's get out our graphing calculator, because part C says, okay, let's type the equation in. 25, try that again, 25 sine 2 pi x over 6, close bracket, plus 25. So far, so good. Alex, what would be a good view window? What's x measuring time? Where's time going to start? 0, you've done physics. Now at first I was going to say 0 to 6, 1 period, but I looked at C, and C actually mentions a time. What time does C mention? You know what, I'll go 0 to 12, 2 periods. Answering your earlier question, how do I find windows? I can't give you a hard, fast rule. You know what the rule is? Be clever. You know, good scale. 5s would be a lousy scale. Oh, you know what? You know what would be a really clever scale? Go up by 1.5s. Because I think that's a quarter of a period. Y min, 0. What's the highest this gets? So what's a nice round number bigger than 50? Yeah, let's go 60. Scale. What would be a really clever scale actually to put on the y-axis? You know what? I'll go by 25s because that way I should be able to see, yes? Graph. Graph. Nail goes up, nail goes down, touches the ground. Nail goes up, nail goes down, touches the ground. Okay. That looks right to me. This here, x value or y value. Look at the units. Oh, x value. Trace 6.5. 37.5 meters off the ground. The height of 6.5 is 37.5 meters. That's what I said. I'll make the C bigger so you can see it. I won't, by the way, in math I don't take marks off for wrong units. Do I in physics? Yes. What's that? Turn the page? Keep going. Turn the page and I need to show you one of my all-time favorite questions. Who's in my physics classes? Am I somewhat partial to amusement park rides? Yeah, okay, I'm fairly nuts about them. Ferris wheels. Is there anybody here who does not know what a Ferris wheel is? You know what? I should not assume that you all know, because we have ESL students here. So conveniently, I did download a picture. Okay? Ferris wheel. In fact, this is the original Ferris wheel that they're talking about in this question. The very first Ferris wheel built was, for the longest time, the largest built. It was spectacular. It was built in 1893 by George W. Ferris. They're all named after him. It was built for the Chicago World's Fair. It took him years to get the funding. He pitched the idea and no banks would invest the money. Finally, he got the investment. They thought for sure he would lose money. It was a huge sensation. But look at the dimensions of this. The diameter was approximately 76 meters. If 3 meters is 1 story, can someone go 76 divided by 3? How many stories high was this in 1893 now? 25 stories. It was one of the tallest structures on the planet. Oh, actually the maximum height was 80 because it was raised off the ground. So 80 divided by, it was just about 30 stories high. The view was spectacular. It had 36 carts, one every 10 degrees, conveniently. Each car held 60 people. How many people could fit on this? Can someone go 36 times 60? Yes? How many did this take at a time? Basically 2,200 people at a time. People waited in line for 7 or 8 hours. It ran 24/7, night and day, non-stop. He made a fortune. It was so huge, the axle at the time took up the steel, took most of the steel on the eastern seaboard for a year. And then afterwards, sadly, it was all resold for scrap metal because you couldn't afford to leave something standing that big upstill. But it was a remarkable structure. Remarkable structure. So let's look at some of this. Oh, I told you I'm interested in several ideas, several key points. The highest, the lowest, the middle. Read this question very carefully. Can you figure out what the highest point is? I think so. Okay, we're back. Sorry, what's the highest point? Can you figure it out? 80. Okay, let's put that there. What's the lowest point? How'd you get a 4? Oh, okay, the total diameter. So you're going to have to use a little bit of logic and reasoning and read. Sorry, I can't change that. Yeah, 4. What's the middle? Now, the easy way to do it is go this plus this and divide by 2. Yeah. 42, which means there's my vertical displacement. Oh, and that's my amplitude, or going in the other direction. What's the amplitude? So h of t equals, there's going to be a 38 in the front. Often, if this is a multiple choice question, you might be done, because there may be only one equation that has a 38 in the front and a 42 on the end. Then quit. We're not done, because they want the full equation. Let's see. Said I want highest, lowest, which gets middle, and then I want 1 point. Assume what? There's my point. That's going to tell me what the easiest trig function to graph is. It happens to be up high. Which trig function starts up high? Are you learning why I taught you? I never ever said last unit starts at 1 or -1. I always said up high or down low or in the middle, right? Or up high, positive cos. Oh, and conveniently, if I go positive cos, what's my phase shift going to be? Nothing. Now, it wants us, the question says, do a sketch. It says show 3 complete cycles. Forget it. I just want to get one good one. So I'm at the top right here, and then over here I'd be at the, let's use blue, Mr. Dueck. Over here I'd be at the top again. When? How long to go around once? Okay, do we want to go minutes or seconds? I'm fine. You know what, let's go seconds to be consistent with physics. So instead of 3 minutes, what will I put here? 180? Oh, hey. Look. Where am I right there, Sabina? Top? Where am I here? Won't I be at the bottom, halfway between them? Oh, and Sabina, can you tell me what point that is? Ah, see? Right? Oh. And won't I be in the middle, halfway between bottom and top? And Dominique, I can even tell you exactly when. I can tell you what time that is. What time? 45. You see how why I said I want to find the top and the bottom, because Asar, then I know the middle, and then you get me one more point, and with the period I can figure out whatever other points you want. In fact, Asar, I think I'd be back in the middle over here again too, yes? Oh boy, that's lousy. Yoink. Oh, Asar, what time? Oh, got a little bit of thinking. I keep picking on you with your bad voice. I shouldn't be. Eric, what time? Yeah. Let's sketch our one graph. What did we say the period was? No. What did we say the period was? 180. So, Ellen, what's B? Oh, heck. 2 pi over 180. There's the equation. I'm just going to move this 42 closer so it doesn't look all lonesome. By the way, if this was multiple choice, would I write in your answer 2 pi over 180? No. What would I write instead? Pi over 90. So I would reduce it in my answer if I'm giving it to you. Like, so just, I'm assuming you can reduce a fraction. Hey, that was positive cos. Just for the heck of it, how about, what if I wanted to write it as a negative cos? Except I'll change colors. How about, it would still be h of t, it would be negative 38 cos. Would the middle of the graph change at all, Tyler? Nope. Would the period change, Tyler? Nope. You know what would change? My phase shift. Where would negative cos start? At the bottom. Oh, t minus 90. I'd accept that. I'd look at you kind of silly and say, why wouldn't you pick the easiest answer? But I'd accept that. Same equation. Oh, what if I wanted to do this as a positive sign? Leave that. Make that a sign. Leave that. T minus what? 135 is when you're in the middle going up. If you want me to write it as a positive sign, fine. Oh, and a negative sign would be t minus 45. I can write whatever equation you want me to. Which one's the best answer? If you can do a phase shift of 0, that's almost always the best answer because that's the least room for error. And it's less typing. So we're going to use the black one that I did. But you understand? Whichever one you throw at me, exactly. All right. C. Oh, I told you, here's what I'm going to give. This is the kind of question I'm going to give you on your test. I'm going to give you some kind of a word problem. I'm going to ask you to find an equation. And then the last 2 questions, I'm going to give you an x value, say find a y value. I'm going to give you a y value, say find an x value, which means we're going to have to type this in. We can do that pretty easily. Let's see. Once you're done yawning, Dominique, we'll clear whatever equations we have here. And we will go 38 cos of 2 pi x over 180, close bracket, plus 42. Enter. What's my view window going to be for my x's? Here's your hint. Look at your sketch. Sorry? I like to see the ground. I'm going to go, I wouldn't take marks off for 4. Let's put the ground on there. Except that's y values. We're talking x's first. 0, yes? To what? Hey, what would be a clever scale? 45s? Since that's what I did. Y min, 0. Y max, what's the highest it gets? 80. 90, 100, let's go 90. Good scale there. I guess I could go up by 4s if I wanted to. You know what? Let's go up by 4s. Because that's what I seem to have as my bottom hash mark. Graph. Ferris wheel goes down. Now the only thing I don't like about this question is you don't get on a Ferris wheel at the top. Where do you get on a Ferris wheel? Most Ferris wheels, to me, if you're starting from a real-time 0, are negative cosine graphs. But whatever. Oh, number 5. Sorry, C. This 5. What word is right next to the 5? X value or Y value? Look at the question. Look at the units. Sorry? Oh, trace. 5. Oh, wait a minute. 5 minutes. How many seconds is that? Uh-oh. Let's go 2 periods. Instead of 180, let's go 360. Graph. Ferris wheel goes down, Ferris wheel goes up, Ferris wheel goes down, Ferris wheel goes up. Now let's go trace. Hopefully this is all coming back to your earlier question, by the way, Alex. How do I pick a good window? You can see I kind of stumbled my way there. But I stumbled cleverly. 23 meters, yeah. H of 300 equals 23 meters. How many seconds after the wheel starts rotating does the cart first reach 10 meters from the ground? Caitlin, this 10, is it an X value or a Y value? Oh, then I'm going to send Y2 10. Graph. And they want the first one. Okay. To the nearest second, 74 seconds. Okay, can you turn back to the very beginning of this lesson? Somewhere near the top of the page, you can write highest, lowest, helps me find middle, which is the vertical displacement. Once I know the vertical displacement, I can get the amplitude. So highest, lowest, get middle. And then the one more thing I want to find, oh, be consistent, 4 period, 1 point. If I can get that, come here, stretch. There we go. If I can get those, I think this question kind of falls apart. Oh, and then I always do a sketch. Even if they don't give me room to do a sketch, I'll do a small sketch somewhere. Because I find, in fact, once I have just the y-axis in place, that gives me almost all of what I need for the equation. It goes from there. Homework. Try number 1. Number 2 is good, but it says sketch 3 cycles. Nah, sketch 1. I figure if you can do 1, you can repeat it. I mean, hey, trampoline. When you're on the trampoline, you bounce up, and when you hit trampoline, you go down. Up. Hey, that's a trig function. Sketch 1 period. Number 4. It says, find what time to the nearest minute that the sun rises on March 11th. You need to know what day of the year that is. How many days are there in January? How many days in February? The question does say no leap year. 28. How many days in March if you're on the 11th? I think that's the day of the year we're talking about. Okay. So, number 4 is fine. 5 is
written strangely. So 1, 2, 3, 4. Ladies and gentlemen, that's it. That's Trig. We are done Trig. Now I got a few more take-home quizzes and some more practice. But right now I'm looking at your test being not next week, but the week after. Probably on Monday, but possibly Wednesday. But I'll let you guys know when I see you guys this Monday, when there's more people in my class.